Now that we understand what demand is, I want to take a moment and look at a particular way that we can describe an individual demand curve, what we call the elasticity of demand. Now, elasticity may seem like a kind of confusing term because economists and business people don't really mean what you might think they mean by elasticity. Really, what we have in mind when we say elasticity of demand here, or really elasticity of anything in economics, is responsiveness. The elasticity of demand is telling us how responsive demanders are. So we know that demand is telling us the relationship between the price of a good and the quantity demanded that demanders would be willing to purchase of that good. So the elasticity of demand is really telling us how responsive people are in terms of how much they would purchase to a given price change. We also know from the law of demand that if the price increases, people are going to buy less. The quantity demanded is going to decrease and vice versa. So really with elasticity of demand, then what we're actually saying is how responsive are people in terms of decreasing their quantity demanded when the price increases, or increasing their quantity demanded when the price decreases. We can state this mathematically as the elasticity of demand is equal to the percentage change in quantity demanded divided by the percentage change in price. And the law of demand tells us that that's always going to come out to be a negative number, so the negative number doesn't actually tell us anything. So for that reason, we're going to take the absolute value of this so that elasticity of demand is always stated as a positive number. Now, there are a number of different ways of making that calculation, but the mathematically most basic way is through what we call the midpoint formula. This will allow us to take the elasticity of demand between 2 points on the demand curve. And again, all we're looking for is the percentage change in quantity demanded divided by the percentage change in price. The midpoint formula then is constructed like this. For a percentage change in quantity demanded, we're going to take the two quantities on the 2 points on our demand curve and subtract them. So Q2 minus Q1, and then divide that by the midpoint between the two quantities, which is another way of saying divide it by the average of the two quantities. And of course, we get the average of these two quantities by adding them together, Q1 plus Q2, and then dividing by 2 or multiplying by 1/2. So that top component then gives us our percentage change in quantity demanded. And you can see on the bottom parts, it's really just the same formula, but instead of quantities, we're looking at the prices corresponding to those quantities. So P2 minus P1 divided by the average of P2 and P1. And that's really all there is to it. So if you've got 2 points on a demand curve, that means you've got two prices and their corresponding quantities. Q2, Q1, P2, P1, then you're just going to plug all of that into this equation, and that's going to give you your elasticity of demand. And just to be sure, we're still going to be taking the absolute value of all of this. So let me give you some hypothetical examples here. Suppose we've got a demand curve that looks something like this. We've got two different prices between these 2 points on this demand curve. One price is $11 corresponding to a quantity demanded of 6. The other price is $9 corresponding to a quantity demanded of 10. To find the elasticity of demand between those 2 points, then, we're just going to take those two prices as P1 and P2, $11 and $9, or vice versa, it doesn't really matter, and those two quantities as Q1 and Q2, 6 and 10, or vice versa, it doesn't really matter, and plug them into our elasticity formula here. This gives us on top for percentage change in quantity demanded of 10 minus 6, over 1/2 of 6 plus 10, and that gives us 4/8 or 1/2 on top. And on bottom, we've got 9 minus 11 over 1/2 of 11 plus 9, and that gives us 2/10 or 1/5. Divide the 1/2 or 4/8 by the 2/10 or 1/5, and you end up with an elasticity of demand of 2.5. Again, we've taken the absolute value there, otherwise it would have come out to negative 2.5. One of the things I want to point out here is it's a very common mistake for students to put the price numbers on top and the quantities on bottom. That's probably somewhat intuitive because if you're thinking about slope, you're going to be looking at the change in price over the change in quantity. That's just rise over run. Elasticity is not the same as slope, and it's important to keep these two distinct. For elasticity, you're going to put the percentage change in quantity on top and the percentage change in price on bottom. So let's just say we have the same demand curve we had before, but we want to find the elasticity of demand between two different points. Here we've got a point of a price of $5 corresponding to a quantity demanded of 15, and a price of $3 corresponding to a quantity demanded of 17. Once again, all you're going to do is plug in those price and quantity numbers on top. That's 17 minus 15 for quantity over 1/2 of 15 plus 17. That's just the average between 17 and 15. On bottom, you've got percentage change in price of 3 minus 5 over 1/2 of 5 plus 3. That comes out to 2/16 on top and 2/4 on bottom, and that comes out to 0.25 for the elasticity of demand. Again, absolute value, no negative number. So the elasticity of demand can tell us some useful things. It's a very common way that both economists and business people will describe the nature of the demanders, the customers, let's say, the buyers of a particular product. If the elasticity of demand comes out to a number greater than 1, then we would say demand is elastic. If the elasticity of demand comes out to something less than 1, we would say demand is inelastic. And if elasticity of demand comes out to equal to 1, then we would say demand is units elastic. Knowing that elasticity of demand can be very useful, not just for economists, but also for businesses, especially businesses who want to consider the impact of a change in price on their revenues. We can state total revenues, or TR, as simply equal to the price times the quantity demanded, the price charged by the business times the number of sales the business will make of that thing. And what we see is that businesses actually need exactly this information, the elasticity of demand, to know what the impact of a price change is going to be on their revenues. Remember, elasticity of demand shows us the response in terms of quantity demanded relative to a change in price. If you think about what happens when a business increases or decreases its price, you'll see that that will have two effects in terms of its revenue. Raising the price, for instance, is going to mean that for every unit sold, the business is going to be making more money, more revenues. But it also means, the law of demand tells us, that if it raises its price, it's going to sell fewer units. People buy less when that thing becomes more expensive. So the question becomes, which is stronger in terms of raising the price? The price hike itself, increasing revenues, or the lost sales as a response from buyers, demanders, to that price hike? So you can already see this is a question of responsiveness, of the elasticity of demand. What we see is that if demand is inelastic, that is, the elasticity of demand is less than 1, then buyers are not very responsive. What that means is a price change is going to dominate the quantity response. A business is going to be able to raise its price, and by doing that, raise its revenue without having to worry too much about the lost sales. Likewise, though, if the business were to lower its price, it would lower its revenues because it would be making less money for each unit sold and wouldn't gain a whole lot of new sales. All of this, of course, works in reverse if demand is elastic. The elasticity of demand is greater than 1. In that case, buyers are responsive. So a price change is going to be weaker than that quantity purchased response. In that case, then a higher price is going to mean lower revenues, because even though a business is making more money for each unit sold, the lost sales and the lost revenues that results from those lost sales is going to outweigh that higher money per unit sold. Of course, if the business lowers its price, the reverse will happen. It will actually increase its revenues, because even though it's losing money on each unit sold, that will be more than offset by that quantity demanded response. It will make more money because it'll see a larger increase in sales relative to the money lost by charging a lower price. And we can see this graphically with the demand curves we just looked at. So suppose a business is charging $9 for its product, and this demand curve represents its customers. According to this demand curve, at a price of $9, it will make 10 sales, say 10 sales per day or per week or what have you. And the business is considering whether it should increase its price from $9 to $11. Now let's think about its revenues at a price of $9. At a price of $9, its revenues must be $90. 10 units sold at $9 per unit. And you can see actually graphically that the area of this rectangle here represents the same thing as the total revenues at a price of $9. Remember that the area of a rectangle is given by the length times the width, and the area of this rectangle is $9 length times $10 width, $90. So this business is considering increasing its price from $9 to $11. We know, of course, that that's going to increase the revenues made per unit, but it's also going to decrease the number of sales from 10 units to 6 units. So for a price of $11, the area of this rectangle now represents total revenues. Question is the component of the old rectangle, the lost revenues from lower sales, less than or greater than the component of the new rectangle representing the gained revenues from selling at a higher price? And of course, you can see this is the component of the new rectangle that wasn't part of the original rectangle, representing the gained revenues from a higher price. You're making 6 sales at a price of $2 additional per unit. So the area of that rectangle right there represents 6 times 2, or $12 additional from raising the price. And then this rectangle represents the lost revenues resulting from the lower sales resulting from the higher price. That's $9 per unit sold, the length of that green rectangle, times 4 units no longer sold from the higher price. 9 times 4 is 36. So we've lost $36 of revenues by losing those sales, and we've gained $12 by increasing the price and making more money on the sales we continue to make. So the net effect is a $24 drop in total revenues. Specifically, revenues go down from $90 to $66, but we should have expected that because we've already calculated that the elasticity of demand is 2.5 between these 2 points, which means demand is elastic, which means consumers are responsive to that price hike, which means you're going to lose money through lost sales in a way that will outweigh the gained money from the higher price. And we can go through the same exercise again, looking at those other 2 points on this same demand curve, a price of $3 corresponding to a quantity demanded of 17, and a price of $5 corresponding to a quantity demanded of 15. At a price of $3, if the business were considering increasing its price, it would again have to think about what it would gain in terms of making more money per unit sold, and of course then also what it would lose in terms of selling fewer units. And in this case, again, this top rectangle then represents the revenues gained from the higher price. That's $2 more per unit sold times the 15 units that the business will continue to sell. And then the green rectangle will represent the lost revenues from the lower sales, but that's only $3 per units lost times 2 units not sold anymore. So in this case, we can see that raising the price from $3 to $5 actually increases revenues, specifically from $51 to $75, but we should have expected that as well because we've already calculated that the elasticity of demand between those 2 points is 0.25. It's less than 1, so demand is inelastic. And of course, what that means for demand to be inelastic is that consumers are not very responsive to a price change. So you can raise the price a bit and not see too much of a loss in terms of lost sales. So again, and to close out, elasticity is a very useful concept, not just for economists, but also for business people and all sorts of other applications, because it tells us the relationship between a change, in this case of price, and the quantity response to that change, in this case in terms of quantity demanded.